Good morning, everyone. We're going to go on ahead and get started. So this is the session, What I Wish I Knew, Career Paths in the Concrete Industry. So hopefully you're in the correct location. I'm not going to spend too much time up here because I know that these guys have some great insight as to the different paths that they followed and what they did in order to get there. So and then we've got a few learning objectives up here, but a lot of it is really in the name. So if you're a student or even a young professional who's unsure about what you want to do after graduating, or if you're not really happy with what you're doing right now, these guys are going to go over some different options for you, and maybe one of them will sound really fun. So.
All right, hi everyone. I'm Samar Haz, a structural engineer with Helix Steel. So our first speaker is Michael Ahern. He's a professional engineer and principal of Pivot Engineers. He started his career in structural design and in an engineering firm, and then he started Pivot Engineers with two other partners in January 2015. The company has doubled in size after a few years, and he is currently the chair of ACI Financial Advisory Committee and the current secretary of ACI ASCE Committee 117. He earned a bachelor degree at the University of Florida, as well as a master's degree and MBA from the University of Texas, Austin. He has a great wife, 3 daughters, and growing company. So let's welcome Dr. Ahern.
Well, thank you for that introduction, Samar. So, engineers oftentimes get a bad rap, and so an attorney once told me a joke. He basically said, essentially, how you tell an introverted engineer from an extroverted engineer. So an introverted engineer essentially will look at his or her shoes, where an extroverted engineer will actually look at your shoes, essentially when you're talking to. And so I don't subscribe to that. I don't believe in that. I'm a proud engineer, and Samar kind of covered this, but in terms of my background, essentially went to University of Florida, got my undergrad, Texas, master's in graduate school. I've got about a little over 13 years in counting of experience, both in design and forensic world, and I joined ACI in 2010. And I've been very fortunate in that experience, and we'll get to talk about that a little bit. And so we're going to talk about engineering and talking about essentially available career paths, at least as I see them, essentially within engineering. Talk about essentially how ACI and essentially the ACI experience can add to that. Basically talk about what I like about being an engineer, and then get into some of the challenges and surprises that I've found essentially as I've gone through my career within the concrete construction industry. And just to kind of highlight, essentially some different ways people approach different problems, and so kind of think about essentially how you might view this problem. So, if we basically take just a simple example where you're looking at a bridge, essentially going over a couple lanes of traffic, trying to maintain a certain clear height, trying to maintain a certain span, and so essentially there's a couple of different ways to approach this problem, and both of them are right. And so it's like whether essentially am I looking at this problem to simply design a bridge, or am I developing a solution to the problem? Like I said, none of them are wrong, which just kind of helps you think about essentially how your mind works. And personally, I'm kind of in the middle on this one, but essentially, where this goes, you kind of think about essentially there's a lot of different options for different career paths in engineering, depending on how you view that first problem may kind of inform essentially what career options that you may find essentially you'd be a good fit for. And so as engineers at our core, essentially we are basically trained to solve complex problems by applying knowledge and essentially principles essentially to that problem. And so that is not necessarily exclusive to a single career path. And so through an engineering degree, essentially you have a lot of different options in front of you. And so someone who might have chosen A, essentially I'm designing a bridge, essentially may be more kind of in line with something on the left-hand side here, and essentially some of it's traditional. And so whereas somebody that kind of views it as a little bit more general, saying I'm essentially developing a solution to the problem, essentially may find themselves, kind of a little more to the right, in terms of, some of the options that they're looking at. And so, and this, kind of this list is really just, attempt to essentially kind of categorize some basic options. By no means is it, essentially fully inclusive, and don't mean to, kind of offend anybody by, kind of these different, buckets, but, essentially this is just kind of a very basic view of it. So in terms of, kind of traditional engineering careers, design engineer, contractor professor, less traditional, construction engineer, maybe designing formwork and shoring, forensic, consulting, facilities, and then on the right-hand side, basically careers that, essentially you're still utilizing that problem-solving skill set, but you're just doing it in a different way and essentially in a different application, maybe essentially outside of engineering, attorney, developer, finance, and essentially these last three are specific just because some of my classmates essentially are doing this exact thing essentially from undergrad and graduate school. And so my classmates that I graduated with from Florida and Texas are basically across the spectrum on this, essentially this list, and all of them still benefit from their engineering degree. Of course, essentially if you're doing traditional engineering, certainly a direct application, but even if you're not doing engineering, you still have a benefit from that engineering degree. But to make that leap, essentially across that line to that third column typically takes a little bit more training or essentially another degree. So for me coming out, basically getting my master's, I went straight through bachelor's and then to my master's. I knew I wanted to design structures. That's what I wanted to do. So I went to basically a great firm, worked for Walsh Moore for several years, essentially designing structures such as trackable roof stadiums, hospitals, stuff like that. But I had a transformative experience where I get to be on site for about 16 to 18 months, and would recommend that to anybody who has the opportunity to do that, because it showed me kind of a different side of engineering, essentially a different way to basically practice my essentially engineering skills and just in a different environment. So I was working, as opposed to working with architects, I was working with contractors. I was getting my hands dirty. I was climbing on formwork, climbing over steel, and really kind of troubleshooting, solving problems. And I found I liked that, and so I liked it a lot. And so what I ended up doing was, instead of essentially kind of focusing on design, essentially I made a transition where essentially I took my, essentially my design experience and essentially had transitioned to, as opposed to doing straight design work, I now basically in forensic work. We're doing investigations. I'm still doing a lot of design, but now instead of doing essentially new design, essentially greenfield design, I'm doing repair design. So again, I'm utilizing those same skills, those same principles through engineering, but just in a different environment. And so the takeaway here is that essentially there's a lot of different options for you essentially within an engineering degree. It really kind of opens up a lot of doors, and it's really up to you to kind of find that right fit, but there's not essentially a single track essentially within engineering. And there's also time to make changes, essentially through the introduction, essentially if you're looking to see what you want to do, or maybe you're not happy with essentially what you're doing, essentially it's okay. Essentially careers are long and you have an opportunity to make changes, and that's just fine. And it's also something that we're is a big no-no in engineering, is that we don't fail. Essentially that's something that's hammered into us essentially through our training, which is good when you're talking about structures essentially standing up. But I mean in terms of your career and thinking about risk, it's okay to essentially kind of take a risk and even fail. There's still time to recover from that, so kind of keep that in mind as well. And also just be aware that according to the Department of Labor, the average person is going to change jobs 5 to 7 times essentially over the course of their career. So don't have an expectation of essentially the job that you accept right out of school is the one that you're going to have the rest of your life. I mean, granted, that's great if that's the way it works out for you, but that's just not generally how things work for most people. So as I mentioned, I joined ACI in 2010, and so before that, essentially I practiced for several years as an engineer, and ACI to me was really 318. Essentially I did not really kind of get beyond 318 that much, essentially in my earlier experience, but essentially since joining ACI and since kind of getting more involved in some other aspects of structural engineering, there's a lot of information out there. There's a lot of great committees, and so there's really no singular path, essentially for an engineer essentially wanting to kind of navigate their way within ACI. And one great thing about ACI as opposed to some of the other professional organizations or industry organizations is that there's very little barriers to essentially to getting involved, with the exception of 318. You're not going to graduate from school and walk in and say, hey, I'm ready to write the shear chapter, so that's just not going to happen. But that said, there's a lot of communities out there that you can get some very, great experience, essentially just by raising your hand for the most part. Essentially it's very low barriers to entry. And successful involvement really starts with that. But I would warn you, essentially just be careful how many times you raise your hand and where you raise your hand. Essentially just be strategic, because at the end of the day, this is volunteer, essentially, and especially if you're graduating, you're basically going to have a job. So basically make sure you're strategic. And so to that end, I'd recommend essentially finding a mentor to essentially help guide your path, someone who's got some experience within the institute and kind of point you in the right direction, kind of give you some advice, introduce you to the right people, say I'm really passionate about concrete cracking, and introduce you essentially to chair of 224, stuff like that, to kind of help you navigate that. And I've been very fortunate that our senior principal, Randy Poston, has been that for me. So my current activities, essentially within ACI, are I'm currently the secretary of ACI 117, which is tolerances, which is not a super technical committee, but that said, I really got interested in that interface between design and construction, and that's why that's become essentially one of my committee homes. Through kind of business school and kind of helping to run Pivot, I've also gotten plugged in on the Financial Advisory Committee, and I'm the current chair of that committee as well. One committee that I'm on right now, but I'd love to be more involved in, is actually Kraken Committee, ACI 224. With that said, I've got, other essentially committees essentially on my wish list. Essentially other committees in terms of what I do and would like to get plugged in on. 562, the repair code, essentially is on my list. 318 as well as 301. So these essentially are some of the bigger documents essentially from ACI, and I'd love to get plugged in on those essentially as I kind of develop within the institute, as well as can hopefully have a little bit more time. But one of the great things about ACI is that there's really so much out there, and so I really have essentially more interest in just that. And so it's impossible to basically be involved in anything and everything. And so, but I'm fortunate that I have some great colleagues at Pivot that are plugged in on these other committees. And so I can essentially stay involved, with these committees, or kind of understand what they're doing, essentially through their involvement. So 318, 435, 364, 437, load testing. It's a fun one if you get a chance to do load tests. And structural reliability and safety, 348, as well as 423 and many others. But, it's been a great kind of benefit to my career, essentially being plugged in on ACI. I really like being an engineer, and so so I'm here to sell you on that. But I mentioned this transformative experience where I was on site, and so I was actually did a lot of design work, essentially on the University of Texas football stadium, north end zone expansion, which is kind of at the forefront of this picture. And so then I got to basically take that design experience and go out on site and implement that. And that's a little bit of a humbling experience, basically having to help build, essentially what you just designed. But it's also fantastic, in terms of the satisfaction that comes, essentially from that. And so it's one of the things I really loved about engineering. I love about engineering is that, essentially seeing something go from a piece of paper or essentially a sketch on a whiteboard to putting that into a model, essentially in SAP or whatever program you're using. Taking that, implementing essentially a set of details and a set of drawings, seeing that into a shop drawing, and ultimately seeing the forms go up, seeing them place concrete, and seeing it being built is just really kind of a neat thing to kind of put your hands on something essentially after you spent, essentially several months, essentially getting to that point through the design process. And also that, for me, essentially when they strip the forms the first time, and that stuff that they teach you in school really does work. That slab is going to span essentially 30 feet and be just fine. The other thing I really like about being an engineer, it's really a chance to be creative. A lot of people don't kind of associate, essentially those two things, but it really is. So on the design side, you're trying to essentially make your design work, essentially within the overall building structure, whatever it is. And so there's a lot of creativity that has to go into that. And in terms of what I do right now, it's very much the case. Essentially, as you add constraints, you have to add, essentially creativity in order to make it work. And so on the repair side, there's even more creativity that's required to get that in. And I really like that about what I do. There's always a new problem to solve. And so I'm always amazed by some of the calls we get currently, but whether it's in design work where essentially just a new type of structure, you're spanning a little bit longer, you're going thinner on the slabs, so there's opportunities to work on hard, challenging problems. And same is true of what I do right now in terms of repair. It may be the similar problem, but it's always on a different structure, and so I never get bored. I also like being an engineer because you understand kind of the way things work. Essentially you walk around in the built environment and you just kind of have a sense of how things work, essentially looking at columns, looking at beams, looking at interfaces, how things come together. And I always like that about being an engineer. And also the people I work with are fantastic, and so they're excited and they're interested in what they're doing as well, which kind of gives me an opportunity to kind of geek out with them too. And so it just kind of enhances my engineering experience being around other people that geek out on engineering as well. So that's a lot of fun. And probably the best thing, this is also kind of a dad perk, is that, essentially you get to share this with your kids. And so, essentially my daughters here are just super excited, essentially to be in front of the stadium as I was showing them something that I helped build. They just kind of don't care. So all things, essentially I really like about engineering, challenges and surprises. I've read the slide after, essentially setting it up, and I don't want to be doom and gloom, but I also want to, kind of talk about, essentially the other side of engineering that, there's things I really like, but there's also some things that are challenging, essentially within the profession. One is, essentially just valuing your time and valuing essentially good engineering. No, it doesn't always happen. Sometimes there's a sense of view, engineering as a commodity. It's not, and essentially people need to essentially value their time in the process. Just be aware that, as an engineer, sometimes there's essentially a higher, essentially expectation for you, especially when you're on the site. So, you just understand that there's risk and reliability kind of around, that and just kind of being aware of that essentially as you're an engineer. Everybody likes doing drawings. Nobody likes to do specifications for contracts. And so they're tedious, they're problematic, but that said, they're super important in terms of the success of the project. And so kind of just remembering essentially don't just go to the details and, kind of the fun stuff, make sure that, essentially the full project is covered because that'll, save you in the future. And just understand that I was, kind of prideful, essentially in engineering saying like, of course this needs to be an 18 by 24 beam, but if that doesn't work, in terms of the context of the overall project, that may not be the, best solution for the project. And so just understanding that, essentially your structure fits within a greater whole and, essentially understanding essentially how you kind of can support that process. And then also just on the job side, essentially recognize that, whenever people think about compensation, they think about dollars. Essentially compensation is so much more than just dollars. Essentially it's the type of work that you're doing, the people that you're working with, where you live, how much travel do you want to do? Essentially what type of, or you mentioned the type of work, what type of, essentially hours you want to keep. So there's all sorts of things like that that kind of fit into the compensation. Kind of keep that in mind in terms of as you're thinking about a job and as you're thinking about your career, and basically make sure that you're asking the right questions, essentially as you're going through an interview. And just understand that, an engineering degree is not a, kind of a means to an end. Essentially it really opens a lot of doors. There's a lot of opportunities essentially within engineering and not just essentially being an engineer. So, and also if you don't like what you're doing, and if you're in the room today, don't like what you're doing, happy to talk. There's a lot of different options essentially to step into essentially from your current role. And so, and I'll end, slide didn't get updated, but ultimately, essentially if you like what you're doing enough to, essentially do it when you're not, essentially being paid to do it. I had a slide here, but one of my contractor friends who's an engineer at Virginia Tech, he went on a trip to Singapore. And so he was looking at, essentially the building, and his buddies were there with him, and he was having a great time. But he spent his afternoon basically taking pictures of davits, essentially off the top of buildings, essentially because he was geeking out, essentially on the systems that they had over there in Singapore that we don't have here in the States. And so if we can all kind of get to that spot where essentially we see the world like that and we're basically still excited about what we're doing even when we're not doing what we're doing is great. And that's, kind of, to me, the success in your career essentially is being happy in what you're doing and essentially like going to work every day and being with the people that you're with. So with that, I guess I'm done and let the next person go.
And in the meantime, so we've got Dr. Armand who's coming up here. He is a professor at the University of Alabama, and he is going to tell you all about going into academia.
Okay. Now this podium is going to kind of constrain me here because I'm used to in class walking around and talking, but that's okay. And because I want to treat this like a lecture, there are handouts which are being passed around. They have a bunch of these fancy QR codes on them, so you didn't have to type in links on your phone to go to the different websites we're going to talk about. But first, a little bit about myself. I'm not what you would consider a true civil engineer. My undergrad degree was actually in ceramic and materials engineering from Clemson University, which happened to beat Alabama in the national championship, which I remind my students all the time about that. And because material science at Clemson was already heavily focused in chemistry, it only took a few extra classes to get a chemistry minor, because I kind of like chemistry. And with that, I was thinking I wanted to go into ceramic engineering for grad school. I always knew I wanted to be a faculty member, but something kind of clicked with me and said, I don't want to be staring under a microscope for the rest of my career. Because most advanced ceramic and material science involves very advanced materials that you can only characterize at the small scale. I wanted to do large projects. So I switched to civil engineering. It was nice that my dad was a civil engineering professor, so I kind of knew what the field was about. And I applied to several places, got accepted to University of Illinois, and I did my master's and PhD there. And then, near the end of my PhD, I was looking for some jobs and looking for some postdoc opportunities. Happened to be chatting with Dr. Weiss at a meeting at Purdue. I said, I'd love to come work for you. He said, okay. And he said he had something to tell me. He's no longer at Purdue. He's at Oregon State. So that was fun. And actually, it turned out to be really fun because Oregon, nothing against Indiana, but Oregon is a cooler state to go, walk around and see than Indiana, especially with my 3 little kids. So I was out there for a while, and then I accepted a faculty position at the University of Alabama. I am a registered professional engineer in Oregon, Alabama, and South Carolina, because apparently, even though the PE exam is a national exam, you have to become registered in the state you take the exam, because after I took the exam and passed, I found out I was going to Alabama. I was like, oh, I'll just apply to Alabama to be a professional engineer there, because I passed the exam. Nope, you have to be registered in the state you took the exam in first, and then you can transfer. So that's why that. And then I'm doing some work in South Carolina as well. Speaking of work, deal mostly with cementitious materials, concrete, ACI, great, all that. Also doing some alkali activated stuff, geopolymers, really cool stuff. I do a fair amount in non-destructive testing. And what I really like to do is implementation. I like seeing what we teach and do in the lab actually be usable in the field. Not everything is usable, but I try to do stuff that you can actually go into the field and do, because to me it's like, oh, great, we have this device that can scan this and tell us all the answers, but it's $500,000 and we can't take it out to the pavement and go scan it. So I like implementing things. Now, academia. Almost always, you need a PhD. You can be adjunct without a PhD and teach certain courses. And more, they're looking for PhDs to have PEs or the ability to be licensed as a PE. And we'll talk about that in a second. But if you have a PhD and you're on your way to PE, you have enough to at least start applying for academic jobs. Now, why ACI and how that can help you is networking. I'm talking to you guys, you now know who I am, and ACI provides a venue for you to get to know some of the important people in the field. If you're here, you're somewhat interested in concrete, so it'd be good to talk to some concrete-related faculty members if you're interested in academia. So networking. But why might you choose academia as opposed to what you'll hear about later and have already heard about in terms of industry jobs? Well, if you like to teach people new things, that could be a good reason. I like teaching people. It's fun to see them grasp a concept that they previously were having trouble with. If you like doing research, you like dealing with the unknown, and the unknown where you can't really be sued, because some of these engineers here deal with the unknown, but they can be sued, and maybe have been, but we won't talk about that. But as a researcher, I can do research and generally not be sued. So that's nice. It allows you to explore the unknown. But just because you have a PhD does not mean you're done learning. You are constantly learning because you're doing research, maybe because you're teaching a course in an area that you don't have a lot of experience with, like I am doing this semester. I'm teaching a horizontal construction course. Well, I've dealt with tons of concrete pavements. I've never looked at a mass haul diagram until this semester, so I had to learn that. I've done a fair amount of asphalt pavements, but I haven't done any rail engineering. So you have to be constantly learning so that you can teach students. And then I put, be your own boss. And as a colleague of mine, who I see every day for coffee, Mike Kreger, told me, a colleague told him, you can work any 70 hours of the week you want, which is kind of true. There's no time clock, there's no time cards to keep track of as a faculty member, but it's not like you just show up for an hour a day and then, yeah, it's good. You have to make your lectures, you have to write proposals, you have to do research, and sometimes have to attend voluntary faculty meetings. Even though they're not really voluntary, you pretty much have to go. So there is a kind of a dark side. Even though you may see it from your perspective that faculty just get the high life and don't really have any responsibility, there's still a lot that you have to deal with. Writing proposals, man, let's see, this past year alone, I've written like 20 proposals. I think one of them got funded. That's always fun, just keep, continual rejection. In class, I swear, every single class, I get a question that I literally just talked about, like 2 minutes before. It's crazy. And I love, let's see, is this a laser point? Yeah. Here we go. Extra credit. I kid you not. Every time at the end of the semester, the last day, what extra credit can I do? Well, you could have just done the work, even mediocrely, to get a C- so that you could at least pass this class. No, there's no extra credit left. And yeah, sometimes this is true. Sometimes we show up to class with no idea about what we're going to talk about and just kind of hope it goes okay. For instance, this presentation I haven't seen in like a month. Whenever I emailed Lauren the presentation, I haven't looked at it since. But having said all that, there is a more serious side that some of the other engineering paths really won't touch on. You have to deal with cheating, academic dishonesty. That is a very serious thing, because if you get accused, and I won't say convicted, because we don't convict, we just state that you have cheated, you can be expelled from college, and you probably can guess that we talk to other colleges. Any other decent college you would apply for will know that you got expelled from Alabama because you violated our academic dishonesty policy. So that could really put a hamper on an engineering career. We deal with sexual assault and suicide intervention. Just this semester, I had to contact our student affairs office about a student who stopped showing up to class very suddenly and was unusual given the student's grades. That's something that you kind of keep an eye out for, and you refer either their name or you refer the student themselves to the appropriate authorities. Fortunately, I have never had a student show up to my office with a sexual assault issue, but I've had other faculty who've, sometimes students feel more comfortable talking to faculty than the police initially, so sometimes you have to deal with that. And I did have to deal with a student nearly losing their big toe because they dropped a steel fixture for the Forney machine on their toe, wearing sandals in the lab. Do not wear sandals in the lab. They did get the toe reattached enough that I think he can bend it mostly. That was fun for the janitorial staff to clean up all the blood. So please don't do that. Now, and these are 2 of my 3 kids, cover now this handout, because this has a little more detail. We'll start with the side that has the 2 big QR codes at the top. Professional licensure. Our previous speaker is a PE. I am a PE, and I think several other of the speakers are PEs. It's a great thing to have. But specifically to academia and faculty, if you go and search for academic jobs right now, I guarantee you about 90% or more will have a line somewhere that says, must have a PE or ability to obtain a PE in 4 years. Why is that? Well, some states require that design courses in engineering curriculums must be taught by a licensed professional engineer. The states that don't require that explicitly are moving to consider that. And ABET, which accredits civil engineering and other engineering programs, is moving towards having more and more faculty be professionally licensed. To some degree, it indicates that you're not always up in the clouds, because I'm sure you've had professors that you would be troubled if they designed a bridge, because maybe they don't know how it works in the real world. So this requirement of a PE is kind of to address that issue. It's not absolutely required, but compared to 10, 20 years ago, it's definitely more of a requirement. and it definitely looks good as a potential faculty member to have that. Specifically with teaching, most Tier 1, Research 1 universities require 2 to 3 classes a year in teaching. Other universities that are not necessarily research active may require 4 or 5. You rarely get to pick the classes you want to teach. It's usually filled by need. For instance, I don't really want to teach horizontal construction, but I have to because there's no one else to teach it, and I'm a low man on the totem pole. Getting an academic job, I just provided 2 links to sites that I used when I was searching. There are a lot more out there. It just kind of helps to have a few places that can search a lot of postings. If you're applying to any public institution, they are required by law to post any open faculty position somewhere on their institution's website. Usually it's like jobs.ua.edu or jobs.clemson.edu. They're required to post all those positions there as well. I will tell you right now, and maybe people have told you otherwise, a lot of the wording in those positions is either extremely vague, because they're just casting a wide net and just actually looking for something, but if someone else happens to come that's really good, they may take them. So you may see a position that says we're looking for a geotech/hydro/transportation position. Well, maybe geotech and transportation kind of relate, but hydro, drainage maybe. They may internally only be looking for transportation, but it'd be nice if they got a good applicant from hydro, they would take it. So just because you see something that's not completely 100% aligned with what you do, don't not apply to it. It could still be worth applying to, because you don't know internally what they're actually looking for. Let's see here. How can ACI help a professor? Well, and this is definitely true in the past year or two, it is so easy as faculty now to get access to these standards so that we can teach them in class. I teach ACI 211 in class. I know Mike Kreger teaches 318 because, well, he helped write parts of it. And it's nice to incorporate these standards into class so that when you do get a job, you can, oh yeah, I know what ACI is. And on the faculty side, it's easy because I log in and it's freely available, and I can tell all my students, hey, sign up for a free account and you get free access to all of these standards. On the research side, because as faculty we do research as well, it's nice because I get to interact with other researchers at these conventions. I get to interact with industry, and I get to potentially get a little bit of funding from ACI to do different initiatives. And so ACI for a faculty member is extremely valuable because it allows me to continually grow and make new connections. Yeah, and there's no order to this handout because, again, I made this at like 1 in the morning. Next one, tenure. That's the big one. All these gentlemen over here need to do a good job. I just need to do a good job for 6 years, and then I can pretty much coast, but not really. It's not that easy. While these gentlemen must continually do good, maybe fail, like was mentioned earlier, but they can't lose their company a lot of money, otherwise they may be looking for a job. After 6 years, I get evaluated for how well I've done those previous 6 years, and the department, the college, and the university votes on whether or not I should be accepted for tenure. Which means if I am, I kind of have a permanent position there. If I just suddenly stop doing anything, well, there are ways to get rid of that faculty member who has tenure but is not doing anything. But it is nice because with very few exceptions, I probably won't be laid off. I may be furloughed, that's happened before. I won't be laid off. And tenure generally, I say generally, transfers. So if I decide, oh, Alabama's no longer a good football school and I want to go somewhere else, maybe like Clemson, go to Clemson, Transfer, well, if I have tenure, they will probably accept that, and I can start there with tenure already. So it's kind of nice. It takes a lot of work to get there, but it's something that's a nice little perk. If you're working or get a faculty job at a public institution, well, your salary is publicly available every single month. Well, it depends on the state, but pretty much any student can go look up your salary. Does anyone know how much I make? $95K a year. You can look that up on Alabama's website. It's publicly available. All these industry folks, it's a little more secretive because it's competitive. They're trying to hire and, get the best of the best and save money because if they're running the company, but public institution, your salary is always out there. So all your students can see it. One student, for some reason, thought I made like $200,000 a year. I was like, I wish. And as a employee at a public institution, you are a public official, so there are some things you can't do. And I put on here, because this happened to a colleague who got in trouble, I can't just go contact one of my industry sponsors and say, hey, I want to take the family, on vacation, can we use your jet? I may be able to do it, but there's a lot of paperwork involved. I can't just, oh yeah, sure, let's go do that, because I'm a public official, technically. Every single year, I have to submit an affidavit showing all my bank account stuff, well, not the actual bank account numbers, but saying I've invested in this, I don't have any ownership in this, so forth, to keep everything above board. Okay, flip the page, soft skills. We had the wonderful, and I've heard that joke before, it's an awesome joke about the introverted and extroverted engineers. And as a faculty member specifically, this is even more important because a lot of your funding for research will come talking with industry and finding out, oh, there's a project here or there, or this agency is in charge of this, and so forth. So it's really important to have good communication skills so that you can be productive in your research career and actually be productive interacting with your colleagues. I put at the bottom of that, basically, I've seen, and it's happened numerous times, faculty members rejected for tenure, even though they have good research and decent teaching, because they just did not get along with their department at all. They had such a big ego that they did not get along with anyone. So why would a department or college want to keep them around? So they reject their tenure application. And at the bottom I put, don't email angry, and try and be like Mr. Rogers as much as possible. It's very important. And it's timely too, because that documentary about Mr. Rogers just came out. I highly recommend it. I grew up watching Mr. Rogers, so. Let's see, summer pay. Nowadays, almost all institutions are moving to paying you only 9 months of the year. In the summer, you pay yourself out of research that you get, if you have research. Now, for instance, that $95K that I make is paid over 9 months. If I budget, okay, fine. I don't need to worry about research those 3 summer months. But if I wanted to pay myself those 3 summer months because I'm actually working and feel like I should at least get paid for working and showing up to the office, and I have research funding, I can pay myself out of the research funding. And at most public institutions, it can only be what your 9-month rate is. You can't pay yourself whatever you want out of research funding. That would be nice, but you can't. Cost. Here's something. In industry, they bid and say, oh, we're going to do this project $50 million. Okay, that's great. $50 million, they figure out internally how to distribute all that and get the project done. On the academic side, when I write a research proposal, let's say a $100,000 research proposal, and it gets awarded. As soon as that money comes to university, about 50% goes straight to university. I never get to see it again. I only have about 50% to play around with for paying students, paying equipment, all that. That other 50% goes to electricity, water, maintenance, equipment, upkeep, and that kind of stuff. I never see it again. It's kind of a shock to some new faculty that that $100,000 proposal is really a $50,000 proposal. But all that's negotiable. Yeah, academia and industry, I do, because I am a professional engineer, I do consult occasionally, because if there's an interesting project or I get a call about a unique situation, it's kind of fun to do stuff outside of research in the classroom. Most institutions will not actively promote that, but they won't discourage you from doing it, because then your name and your institution's name is out there for a lot more people to see. And then finally, and I put this at the very end on purpose, imposter syndrome. You're going to be surrounded, if you do get a faculty job, by a lot of smart people. They all have, well, most of them will have PhDs. Very smart people, and you may feel like, well, I don't belong here because I'm not entirely that smart. And it's happened to me. I know if you get a faculty job, it'll probably happen to you too, because you're surrounded by the, I want to say, academically elite. Not necessarily intelligent, academically elite, because there are some not intelligent professors that are academically very good, but intelligence-wise, maybe not. So you may have a feeling when you're working and sitting in your office like, man, I can't believe they gave me a faculty job. I was a grad student like 6 months ago. Now I have to write proposals, I have to find funding for my students, I have to attend faculty meetings, I have to address this issue with the state senate because they don't like my research report, which that's happening to me right now. It's a lot going on. And so you'll probably experience that once, maybe multiple times during your early career. Having said that, at the bottom there's just some links. And as Michael said about failing, the bottom right link, and it's just suitable that Michael graduated from UT Austin, the bottom right link is the commencement speech that Admiral McRaven gave in 2014 at UT Austin. I highly recommend you watch it completely, not just the part where he says make your bed, because that's the only part that people ever remember. I think the more important part is you will fail, just learn how to recover from your failures. So with that, I'm done.
All right, our next speaker is Mr. Edwards, Joshua Edwards. He's a professional engineer and vice president of engineering at AVR. Mr. Edwards has over than 20 years of engineering, concrete production, and material science experience. He received a master's degree in civil engineering from the University of Minnesota. He is an active member of Minnesota Concrete Council, NRMCA, and ASTM.
So I took a pretty strange path to get to where I'm at now. I started straight out of high school working for a testing company, consulting testing company, and did that all while I went to school for my bachelor's and my master's. So I started with my master's and my bachelor's in civil engineering with a geotechnical emphasis. I wanted to be a geotechnical engineer. I thought that's what I wanted to be. I started to write a whole bunch of geotechnical reports, and I found out that that was super, super boring. And I didn't want to do it anymore. So I was kind of in my master's at that point too, so I kind of switched to a materials emphasis and started to do a lot more materials type things. While I was working for this engineering company, I did a bunch of work for a ready-mix producer. There are many times when a ready-mix producer needs a professional engineer to sign off on documents, all that kind of stuff. A lot of that we'll go over in a minute. But needless to say, I did that for a number of years, and then I was doing so much of that, they asked me if I wanted to come work for them. I told them that is absolutely not what I would ever want to do. I had gotten my engineering degree. I wouldn't want to go work for a producer that's just making concrete all day. That even sounded super boring. So I said I didn't want to do it, and they said, well, you got to at least come listen. And 12 years later, that's what I've been doing. They made me an offer I couldn't refuse. So that's a little bit about me. We can skip that. So today I want to go over some potential career paths. A lot of people who get engineering degrees don't think about ready-mix concrete. They don't think that we would need engineers. I actually have 4 or 5 engineers that work for me on a daily basis, and I can give you a little bit of what their day-to-day looks like. How ACI impacts what I do every single day. Some job opportunities kind of outside of what I do, as well as what a day-to-day life of a ready-mix producer looks like, and some challenges. So a little bit about what my company does. So we're a large ready-mix concrete producer in Minneapolis. We produce 750,000 yards of concrete on any given year. That is a boatload of concrete. That's roughly 5,000 to 6,000 yards a day. So we're sending out 600 to 700 trucks on any given day with concrete that is getting old the second we make it. So if you can imagine shipping stuff around a town in traffic, all that stuff, which I'll go over some numbers in a little bit. So you're doing that 600 to 700 times a day with concrete in a truck that's roughly about $1,000 to $1,500 a truck. And in 90 minutes, it's garbage. So when I first started in the industry, I was, again, a consulting engineer, and you had lots of time to think about all your words very carefully. There was multiple reviews of your documents. You could always, I'm not exactly sure if I should say this or I should say that. You always had somebody to talk to about what you should be saying and when you should be saying it. And if your report that you sent out was a week late, no big deal. Nobody ever died from a lack of a geotechnical report. In my industry now, I literally have 90 minutes, and for every 90 minutes that's wasted, it's $1,000, $1,500. That's garbage. And when I show you the numbers here in a little bit, it's not just that truck that showed up that's getting rejected. There's probably 10 more behind it that are also potentially wrong, that will also maybe get rejected. So it can start to pile up on you in a hurry. So hopefully at the end of this, I won't be so super negative of how it can be, but it can tend to be a bit negative. But we have dispatchers. I'll show you a picture of what they do. So they're our order takers. They need to be really highly trained on all the different types of concretes that we make. But probably the biggest use of engineering students is in our quality control laboratory. We have a laboratory where we make all of our concrete mix designs, and then we have field technicians that go out and do the testing and to make sure that the concrete is meeting the specifications that we want it to meet. So we do so much work that we'll actually test the concrete before the testers test the concrete to make sure that we're correct when we get on site. And then if the tester tells us that it's not right, then a lot of times we'll tell the contractor, don't listen to that guy. We're better than that guy, just pour it. That happens a lot. So field technicians and then engineering staff. I have another engineer that works for me just with the amount of work that we do, submitting mix designs, pretty common for those mix designs to come back and maybe need some tweaks and stuff. So we're constantly sending out mix designs, making new mix designs. When I started at AVR, we had 200 mix designs. Now we have well over 1,000 mix designs to choose from. Any number of things we can do. We got concrete all the way from 100 PSI, kind of lean fill, flowing sand, all the way up to 18,000 PSI concrete for high-rise structures. So it's amazing the amount of things that we can do with concrete, and it just is a ton of R&D. I have 3 lab staff. That's all they do all day is just make concrete that we haven't even produced in mass quantities yet, just for the next stuff, add mixtures, that kind of stuff, and what we can do better. So that's what a lot of those guys do for me. They are on any given day. I have 3 field quality control guys as well, so they'll just go around to the jobs every day and make sure that that concrete is meeting specifications. They do a lot of arguing for us. They're kind of our last line of defense to make sure that that truck that shows up on site gets poured, because that's the last thing we want to see is that truck come back to the yard full of concrete and then we have to throw it away. So I'm just going to mostly focus on ready-mix concrete today because that's what I do, but there are these positions in pretty much all of the manufacturing fields. There's a precast operation, so they're making concrete precast elements at a yard, very similar to our plant, but they'll make and cast that thing there, let it get hard, and then ship that out to the job site. There's precast pipe. There's all of the concrete products, so they're making retaining wall block out of concrete, all of these other kind of stuff. They'll have all of these same things that I talk about as well for job opportunities that we have in a lot of those other facilities. And with the consolidation of our market that we've had, there's not a lot of really small ready-mix producers anymore. They're kind of grouped up and they become monsters like us and they're making 1 million yards in a year. They need all of these jobs filled. So ACI impacts. I went to about as much school as you can go to, and I can tell you what I do on any given day was not taught in school. You'll learn about concrete materials in school for maybe a semester at best. And then after that, you just do this funny hash mark whenever you're talking about concrete in a drawing or something like that. And you don't really ever get to know how that concrete is really made. You'll know the basics, of course, but you'll have absolutely no idea on how it's really made. After this, if this sounds any interest to you, just call up your local ready-mix producer. I guarantee you they'll give you a plant tour, and you can actually go visit a plant and see how concrete is made. It's pretty eye-opening, which I'll show you here in a slide on what it actually entails to make concrete on any given day, and it's pretty nuts. So I got the lion's share of my education from going to ACI and networking with professionals and meeting all of the people that were doing some of the things that we were trying to do. I remember when we started to get into self-consolidating concrete, in mass concrete, I made sure that I got myself on the SCC committee or the mass concrete committee to learn as much as I could. You know, with SCC concrete, you're making concrete that looks nothing like any concrete that you've ever seen before. It's super scary. And now you're going to send this truck out, you know, that's a 22 to 26 inch spread. And we had a lot of times where we would send it out to the job and the contractor would reject it like this. You had to have screwed this up. This doesn't look like anything I've ever seen. Like, no. We spent a lot of time making sure that it looked like that. Just trust us. It's going to be okay. And all the while we're thinking, man, I hope this turns out right because this is the first time I ever made this. And we're hoping that it's good. And there's a lot of that. You don't have a whole lot of time in my industry to second guess and do all that stuff. You just do it. But that networking, the being on all of those committees is extremely helpful. You look at any of the 200 or 300 series, they all play a role in what I do every single day. And if it doesn't now, it probably soon will. It wasn't until pretty recently in our market we started to get into a real lot of mass concrete applications in our bridges, and we're starting to build quite a few pretty tall buildings. So I made sure that I talked to all of the people at the Mass Concrete Committee and started to learn about what we needed to do with our mix designs, and then I got all the people that work for me on making mixes with a lot of slag and a lot of supplementary cementitious material. So we knew how those worked so that we could send those out and not get them rejected. So job opportunities, it's amazing on what you can learn in this job in pretty short order. So this is kind of just to give you a little bit of glimpse at the numbers of what a day looks like in ready-mix concrete. So on any given day, we'll have orders being placed with our dispatchers. So we'll have 100 plus contractors that we work with, and they'll be ordering concrete for 200 plus jobs on any given day. So each one of those jobs will have somewhere between 5 to 10 mix designs that contractor can choose from. You know, contractor A is going to be pouring footings today. He wants 50 yards of that, and he wants a truck every 10 minutes. So that's what that dispatcher is putting in. Hopefully he chooses the right mix, and all of that stuff goes according to what it should. And they're going to send those orders out to the concrete plants that we have, hopefully strategically placed around some type of metro area. So those plants are all different. They're in different locations in the city. We have 10 plants in and around the city of Minneapolis. They all have different cement and fly ash combinations. They all use different aggregates. They have different batch men. You know, they have one of these 1,000 mix designs to choose from. Again, hopefully they're choosing the right one. Hopefully we've sent it down to them that says, you know, use mix 1, 2, 3, 4. And then they're going to put that concrete on one of 150 trucks that we have. And that truck is going to deliver that concrete, and it's going to deliver it in traffic, in weather, all the while it's getting old. Hopefully it gets there on time and in spec. We pour that, and then we just keep rolling down the road. Now we'll do that. Like I said, we have 5,000 to 6,000 yards any given day. So we'll do that 650 to 750 times in a day. And what we shoot for is about 4 to 5 loads per truck. So we do that from 5 in the morning till 7 o'clock at night. When it goes well, it's awesome, it's clockwork. I get very few calls. When it doesn't go well, it becomes a very long day. But the good part of my day, usually if it's going to go bad, it's going to go bad early. So I don't answer my phone much past noon, which is a good thing. But there's lots of times where I get a 5 o'clock call like, hey, wait a minute, this doesn't look right. That's usually all I'll get. This doesn't look right. We don't think we should use it. And every decision that I make is a $1,500 decision. And it may be not even $1,500. So what a lot of people don't realize when they're looking at ready-mix concrete, on a given job, say that we're gonna pour 500 yards of slab on grade on a job an hour away. Most of those contractors are gonna want that concrete to come to them at roughly 100 yards an hour. So by that time that first truck shows up on site, potentially wrong, almost 100 yards are already made and in transit somewhere. Just waiting to show up to be wrong again, probably, because they just kept making it wrong the same way. They just hit a button. That's all the batch man does is he looks at it, okay, this is what I'm making, and he guesses at lots of things. He guesses at where the slump needs to be, where the air needs to be, where a lot of these things that we test on site need to be, and he just assumes they're going to be okay based on what he's done in the past. And maybe they're not today. And that's why we have people out on the job site figuring out if they're right or wrong. And believe me, as soon as they get that first truck and they know it's wrong, they know those other 9 trucks are coming. And now they're tightening up their boots and getting their gloves a little bit tighter because they know they're going to have some work for them, because that's what they do for me, is to try to get as many of those passing and as many of those, at least number of those rejected as they possibly can. So it can get to be a bit maddening sometimes, but I tell you what, for learning on the job and learning quickly, there's no better way to do it than that. You spend a week doing that and you will learn about everything you need to know about concrete in a real short hurry. You become a huge resource. So you're constantly working with contractors, and all they want to do is get the job done. They know what they need to do. They're going to be heavily reliant on you to give them what they need to make their job easier for them and their guys out in the field. So I can tell you probably 90% of what I do now is to take concrete and get concrete to do what it doesn't usually like to do. So I'm getting it to flow into places, I'm getting it to get higher strength earlier, I'm getting it to set faster, getting it to do all of these things that I know I can do with concrete, but they haven't learned all of that. They're contractors, they may know, a lot of them know quite a bit about concrete, but with the chemicals that we have today and with what we can do with concrete, and when I started at AVR, we had 8 admixtures. Now we're plumbed for 24 admixtures in some of our big plants. There's nothing that we can't get the concrete to do, provided that the contractor calls and asks, hey, today I'm going to try to do this. I need to pump it, 200 feet through 3-inch line through. I mean, there's any number of things that we do on any given day, and they become a huge resource in helping that contractor figure out his problems. And once you do that for a contractor on a couple of occasions, then you kind of have a friend for life, and they're going to call you. I get calls, probably 50% of my calls now are on jobs that we're not even supplying the concrete on. Like, hey, I had concrete yesterday, it didn't look quite right. Is there something that you think that we should do? I'll tell them, hey, I think you should call your supplier and ask them if they have X, Y, Z, or ask them if they can do this, or they have a mix that looks kind of like this. When they're outside of our market, there's many times where I'll just send them a mix design and say, hey, or have them see if they can make this. And that is a huge resource for them, and they are super appreciative. Challenges, as you can imagine, there's lots of challenges. Probably the biggest challenge that I deal with is time. So we're up against the clock. I constantly talk to my boss and say, why on earth is this even a real thing? I can't imagine anybody would sell a product that gets old in 90 minutes and travel around the city with it in traffic, in weather, and all this stuff. Just to get it, and we think about shipping in general, the Amazon or whatever. I mean, they're selling you something and they're shipping you something. If it shows up a little late, okay, you're not real happy about it, but it showed up on Tuesday instead of Monday, okay. And it wasn't quite right, but it's all right. You can always send it back. We sell a product that gets there and it either meets specification or it doesn't, and it can get rejected, and it gets rejected sometimes more than we would like. We average about a 1.5% rejection on any given time. So there are some stuff that gets rejected. We deal in a pretty highly technical market in Minneapolis. 18,000 PSI stuff, some real high slump flow stuff. So it can get pretty intense. But this is the guy that you got to make happy. He's out on the job site, and everything that you do wrong just affects this guy, and he's ornery usually. He's ordering when he gets up in the morning, and he goes to bed ordering, because everything that you do that isn't exactly right just makes his day worse. And that's usually the call that I get from this guy, and it's any number of things. But you know what? At the end of the day, once they understand that you're doing what you can do, which is in their best interest, they'll lay off of you. I can tell you, everybody that I've hired has had a run-in with this guy at one time or another, and they quickly tell me, I have absolutely no idea why you got me into this industry. But once they get a hold of you, and they know that you're in it for their best interest, they'll lay off, and they know that they're just trying. They're under the gun too. They want to get this stuff built as fast as they possibly can, and as cost effectively as possible. So that's all I have. It's a pretty crazy industry. It's nothing that I thought I would ever get into, but I mean, there's a huge number of benefits. The amount that you learn in pretty short order is amazing. Great individuals. They pay super well, as you can imagine. I mean, we pour 750,000 yards of concrete a year. Each one of those yards is $110, $115 a yard. There's a boatload of cash coming in, and so they pay you well. Another huge benefit is we got no time for any kind of paperwork. It's just do it. There is not a single piece of paperwork that me or any of the people that work for me fill out. We have no time cards. We have nothing. It is get it done. I'm going to give you a job, and I'm going to assume you're going to get it done. When you're not getting it done, we will have a discussion. As long as the concrete's going out there and it's not getting rejected, I'm assuming that you're doing your job, and we can talk about vacation time in the winter sometime. Thank you.
Go on ahead and introduce Andreas. He is a junior engineer for flood testing laboratories in Chicago, Illinois, and he is going to talk to you all today about going into the construction industry.
Morning. My name is Andres. I'm the junior engineer for flood testing. So I have to excuse my beautiful voice today. I was in the student competition explaining the mixed design to 52 teams, so I kind of ran out of voice at some point. So, what I wish I knew. I finished my degree in July. Well, let's go to the agenda. Just to use it because I put it there. This is the agenda. Great. So, I finished my bachelor's degree in the University of Puerto Rico at Mayagüez in July 2017, so last year, sorry. I started in flood testing in November last year, so it's more or less about a year now. Currently, as they say, we are all liable, so thankfully I don't have the PE yet, so I will be liable at some point. I'm in that way. My career path is kind of the opposite of Mr. Edwards. My background is concrete, and I end up being a geotech. Yeah, so it's the complete opposite. I'm a member of these committees that are there and the chair for SL5. And my areas of interest is obviously geotech, because I have to. Construction material, because I like breaking stuff and getting paid for it. And testing. Construction. I never knew there was a business called testing services in construction when I was in college. So when I get approached by the boss, I was like, oh, what is testing? What that means? I know ASTM exists. I know you have to deal with the quality of the stuff, but how is that testing business? So it's part of the construction part, because you need to make sure everything is working. So at some point you are all going to get this. This is my actual diploma from the University of Puerto Rico. And then you are like, what do I do? Like, I have a piece of paper that says that I know how to do something, but man, yeah, about that. Can be hard sometimes. So, what is testing? Testing is all about getting information. It's all about making informed decisions. Is this working? Is this going to work? Does it meet the requirement? That's what testing is. Obviously, you need to keep the rules, because it will not be fair if everyone can test however they want. That's how and why ASTM exists and ACI, etc., etc. So you have to follow the rules, but it's basically knowing what you're doing it right, doing it the same way every time, so everyone have the same results, and if it's wrong, well, you just call the concrete guy and say, hey, here you go, your 30 trucks are back, and he will be happy. Yeah. when you send trucks back. They don't like it, but sometimes happens. Sometimes happens. And you get a lot of problems. A lot of problems. Oh, we dumped the truck there, we poured concrete, and it was 10 below. Do you put air on it? No. Yay, take it out. That type of problem solving, and then you have a cheat pile, and the cheat pile is moving, and they call you, hey, we have a crack, 7-inch, and you're like, hey, nice, good crack, and you run. But then you have to go back to them and call and solve it. So this is part of what we do. The lab have been around for 100 years, 105 to be more precise. So we kind of poke into everything in the Chicago city, from soils to asphalt to concrete to whatever. Basically, if you can build it, we can test it. That's pretty much it. But after you know this, how you decide, when you're out of college, how you know what you want to do. It's weird. In my case, I wanted to do my PhD and go back to teaching. That was my career path. That's what I wanted to do. So I did research for 10 weeks in Oregon State, and then I didn't get the funding. So what do I do now? Well, let's go to work. But how? So the how is it's gotta do. So you have to talk to professionals. That's why you come to ACI. You talk to professionals and say, hey, here you have a panel, professors, industry, designers, testing industry. You ask questions like, what you do, how you do it, why you do it. But in my case, I like getting paid for breaking stuff. But it's your interest and finding your own path. Even though we all have a civil engineering degree, we all don't like the same stuff. So it's you asking questions. And ACI is a very good place to ask those questions. The role of ACI is very important. Why? Because when you go to a committee, you know the rules of the game. Because if you like to design bridges or design structures, you are going to use the ACI 318. Period. There is basically no way around it, unless certain different situations. But you need to use the ACI documents to design and perform. And you know key people. You may go to a committee and sit down, and the guy in your side is probably the guy that wrote the book you use in reinforced concrete class. And you're like, so what better opportunity to ask questions than the actual guy that wrote the book that you're using? I mean, don't ask him about the mistakes in the book. Don't do that. It doesn't go well. Doesn't go well. No. You just say like, oh, what do you think about this? And they will be like, oh, I messed it up. Or they will give you the actual answer and then you figure out that you were wrong. But it's that exchange of opinions and asking questions of how it works and why. Now, ACI have something called certifications. This is extremely important, especially when you are starting your career. Why? Because when you get certified, you gain your client's trust. Because if I call the ready-mix company and say, hey, this truck doesn't meet the specs, and I'm not certified to check that, which I'm not, don't worry, they will question my opinion on it, because I don't have the training for that. But if I call them and say, hey, this doesn't meet, this is my ACI field technician number, and they look it up and, okay, this is an actual guy that knows, or is supposed to know what he's doing, there is a trust there. They take your opinion as a formal professional opinion, and it's very important in this business to have the trust of your clients and your colleagues, because if you go around lying to everyone, at some point it's going to come back. It's going to come back. And as I told my friends, if you are a doctor and you make a mistake, you just put a 6 feet under dirt and tap it and done. If you are a car mechanic and you make a mistake, the car will be back in 2 weeks. That's it. If you're a plumber and you make a mistake, you just change the pipe or blow it, depending. But if you're a civil engineer, your mistake is going to stand there 50 years, or it's going to go down, which is worse. So think about your career, where you want to go, and also help with your professional development as another achievement. And it looks good in your resume. The role in the ACI, networking. I think it was basically in all the preceding presentations, networking was there. Why? Because you get weird jobs. Weird job is like, oh, we have this concrete with these specs, and you are like, what is that concrete? And I have never seen this stuff in my life. You ask people, you go to that committee, when you get that job, you know who to call. Like, hey, I have this, do you know, have you done it before? That's weird jobs. And they appear. They are going to come by because there are weird people out there. Equipment. You go to the exhibitors and you're like, ooh, pens, ooh, notebooks. No, that's not the importance of the exhibitors. The exhibitors are to learn what they sell and why. They have an air meter. Humboldt is here. They are not paying me. Gilson is also here. You go there and you have never seen it, you ask, what is this for? How does it work? How do I take it apart? Because that's how you learn what tools are available for you when you go to the field. You see the compression machine that Forney had for this is a good announcement because they help in the student competitions, but they have the compression machine. You go there, you ask questions, how this thing works, how much it is, how do I fix it, how do I break it? Because, yeah, I broke one, but that's another story. Yeah, I blew a hose. Anyway, you ask because that's the tools you're going to use when you get to a job site. And you get experienced professionals. You talk to them. And this is me when I was younger, and this is when I first met this guy. So I went to Denver. It was my first convention for pervious concrete, cementitious efficiency. So I won. And yay! Okay? So, then I received a job offer, and you remember this picture? This guy decided to hire me. Yeah. And you don't think about it. I never expected. And he's kind of nice, I have to say, because he's standing in the back. But, networking. You come to the student competition and you never know. And I was just floating in a place full of water by the four sides, and basically no power, but that's not the point. And I received a call from the guy that gave me the prize when I won my first competition. That's how ACI works. That's networking. That's talking to people. That's asking questions. That's looking for your career path. And it's kind of nice working there. You never know when it's going to happen. Challenges in this industry. The pros. Let's go with the pros. Good things first. Different projects every day, because in the testing industry, you are not married to one project. You have a lot of projects, because if they are throwing a sidewalk, you go in, you measure the concrete, you check it, or rebar. Or if they are doing a high rise, you go to that high rise. It's a wide range of projects that you can see, from soils to concrete to rebar to, hey, can you test a window? What? No, but that's ACI. We had another person that we know that, yeah, he tests windows. I didn't know you can test a window, but there we go. Different people every single day. You go to a job site and you met a very nice foreman, and he's like, hey, welcome back, and then you go to the next job and they are like, what are you doing here? Go away, you're late. It's different people and you have to be able to deal with them. Different situations, obviously every project is different. Oh, I love this one. The oh my god moments. They call and say, hey, and when they say that, they broke something. They call you like, we need an engineer. Why? We found water at 8 feet. What's what the geotech report said? Water at 5. Did you read it? Yeah. The water's there. There's nothing I can do. It's there. Pump it up. But they don't read. Let's take note of that. People don't read in construction sites. And the relativity of time. It's a very deep concept in construction industry. You know why? Because there is the time it stretches. When they have to sign the proposal and actually pay you, the time is long. It's like 8 months. Then you actually drill, perform the work, and I was drilling the last hole, and I received a call, like, hey, when is the report going to be in my office? Well, I'm just drilling. So yeah, the time is completely relative. They don't want to pay, they extend it as much as possible, but they want the report like before you actually do your job. So be prepared for that, and you just ignore. Sometimes there are some plans that you cannot do that. The cons, yeah, it's actually the same. Because it's not what happened, it's how you take it. Because they can call you 10 times in a day, that happened. But it's how you take it, how you deal with it, how you canalize that. We are engineers, we solve problems. And a call, trust me, it's a problem, because it's time that I don't get to be in Facebook, doing my geotech reports. So it's how you canalize that and how you put it in its little pocket, like, okay, it'll be there at some point. It's on you. The cons are on you. And sometimes you just pour concrete over it. It works. It works. For me, work day is a fun day because I get to the office and I don't know what I'm going to do. I truly don't know. Sometimes I get to the office and I think, okay, I'm going to be doing reports, and suddenly my boss says, hey, here you go, floor flatness today. 79 floor, 868 feet in the air, 50 degrees, and you only have a hoodie, and you come from a tropical island. Yeah, it is fun. And then the guy is like, no, we're not done, you have to wait 20 minutes, and you're in the corner like, yeah, sure, no problem, I'm fine. But it is fun, it's a good view. And it's a different view every day, because what you learn in one project, you can apply it and use it in the next one, and it's such a rewarding experience to, okay, I messed it up in that one, yeah, but in the next one I do it right. The first time I did floor flatness, I did it you have to do it in 90-degree angles, and I did it in diagonals. It was a beautiful report, but I learned my lesson, At least the machine still works. So you get to see some fun. The first one is a light post, that they were supposed to do a deep foundation for it. There are 20, 30 feet something. So they were not sure if they poured the concrete, concrete people don't send the trucks. So we cored between the bolts of the base, and we found that, let's say 30 feet of foundation, 10 feet of concrete, 20 feet empty, and then concrete at the bottom. Well, yeah, there was part of the foundation missing. To this day, we don't know where it went. So that happens. The middle one, this is a core we have in the lab. This is concrete, and this is the actual bedrock somewhere in Chicago at 115 feet. Yeah, it's down there, and you don't get to see this every day. So it's so nice how the actual caseman gets into the bedrock. I have never seen it. For me, it's amazing. And then you see this one, and you say, okay, it's a traffic sign, the base broke. Yeah, no big deal, But then, when you are in the inspection and testing part of the construction industry, you look at this and you say, hey, that traffic sign is in a seismic region and hurricane-prone region. So that goes to the other section of the ASCE 705 or 710. Where is the rebar in that picture? That's when the testing industry comes in place. Because that thing it is supposed to have rebar. Okay, so those are the things that you get your eye trained to. Sometimes you are just hanging there and you feel like a photographer and an artist, and you just take pictures of the slurry out of the drill rig because you're bored sometimes. Sometimes you're drilling and you discover new soils. It's called blue sand. But no, it's just that there was a cleaning company somewhere and they decided to throw solvents in the soil, and there was slag on the soil. Ta-da! There you go. And sometimes you have very good drillers. They are very precise, and they get a tire. Don't ask me how. But he sent the auger, and the tire started spinning, and we're like, what is that? Hopefully, nothing alive was there. And that's usually nice, not finding living things under the auger. But yeah, you find it's fun, trust me, it's fun. If you tell a professor that you can do a 12 feet cantilever cinder block wall, they will not believe you. Ta-da! It is fun. I'm telling you, it is fun. And then you see this and you go like, oh, it moves, okay? So This is the type of stuff you see. That's a pipe used for an inclinometer reading. You just drop a level and take it back, and it's very easy test to do. But you know, sometimes people don't know how to drive, and you have to restart your machine. See, that happens. But this is what you get. This is the vista of Aqua from Wanda, which is not done yet. So you get so much different scenes and pictures, and you get to see the city in a very different way. And the thing I like about my job is that I can go from doing research in the lab that my boss haven't allowed yet, but I do it, and play with ASR and shrinkage and cementitious efficiency and fly ash, and then go up there and just watch the city and enjoy the city, enjoy where you're living, enjoy what you're doing. And you can go from a very big hole, it's huge, to the tallest building for 22 years, tallest building in the world for 22 years, just to look at it. Or you just eat pizza in front of a drill rig while they are drilling, which is sometimes nice. Yeah, that's my pizza. It was very good. It doesn't have pineapple because, no, pineapple doesn't go on pizza. No, okay? But what I wish I knew, I was going to have this much fun. And if I knew that, I will actually put attention to my calculus class and actually pass it the first time. And actually finish sooner, because if you do what we told you to do, talk to professionals and find your space, you're going to enjoy it, and it is a lot of fun. And some people in the industry use this for testing. It is a tool, it's not in ASTM, it is a glass ball. No, it doesn't work. No, it doesn't tell you the resistance of concrete. And you don't guess, you test it. So it is kind of nice. We have the question section later, so thank you very much. And if you have a question, well, feel free to ask.
So our next speaker is Dr. Mohammed Al-Batni. He is a PhD and SE at WJE. He received his master's degree and PhD degree in civil engineering from the University of South Carolina. He has a background and interest in structural evaluation of existing structures and repair. He is a secretary of ACI 444 and voting member of ACI 342 and 437.
So good morning, everyone. Again, my name is Mohammed El-Batanoni. You see a SE after my name, that's like a PE, but just for structural engineers. It's a much harder test, but then you get a license. So today we listened about different careers in engineering. So we started with engineering, which is what I understood as more of a design. And I graduated from Helwan University in Egypt in 2008. And my first job was as a design engineer. So I actually worked as a design engineer for 1 year. It was so much fun to see buildings that you put in drawings being actually built. I didn't actually stay in Egypt long enough to see it, because I came to the US in 2009, got my Master of Science in 2010 from the University of South Carolina. I also got a PhD from the same university in 2012. And then I spent 2.5 years as a postdoctoral fellow and adjunct professor. So I was teaching, doing research, writing proposals, doing these budgets and all these things. So I actually touched these two fields. And now, today, I have been in WGE for 3.5 years doing consulting work. And my presentation will really talk about why consulting is unique and fun and interesting and everything. There is a lot of overlap with the last presentation because we do also a lot of testing. But consulting is unique because it's all about solving problems. It's like putting different pieces of a puzzle to give your client a solution. Our approach to do this is very interesting because we basically do this. We ask the structure. So this was a sentence said by the founder of my company. My company is called West Janney Elsner. So this was said by Mr. Jack Janney more like than 60 years ago, and it's still valid today. When a client comes to you and tells you, like, I have an existing structure, because this is a lot of we deal with is existing structures, and they have a problem in that structure, the first thing you want to do is to go out and take a look at the structure, right? Because that might give you a key to your solution. And then every structure is also unique. They are all different. You can't just rely on drawings. So a lot of our work, maybe 25% of our work, will be going to the field, doing inspections, taking material samples from the structure and testing them in the lab to understand what the problem is and to try to provide our clients with the best solutions. So the next thing is the diversity of projects. This is something that not everyone knows. Like when I was a graduate student and someone tells me forensic engineering, I would think, yeah, forensic engineering are people who, when something collapses, they go out and look at it and try to figure out why it collapsed. This is not all what we do. We do that sometimes, but a lot of our work is on repair, rehabilitation, and figuring out problems. You would be working on several projects at the same time. They don't usually tell you this, but it happens. You will get in the morning and you find a new project that you need to do now, and you have 10 other projects you're working on already, and you need to provide reports for all of them. So we have a lot of diversity on our projects, and this also includes diversity in the services that consultants provide. You can be an expert in many fields, like non-destructive evaluation, structural health monitoring, which is what I do a little bit, load testing, repair, corrosion, service life prediction. So there is a lot of fields that you can get your hands on depending on where your interest is and, of course, where your background is from. The other thing is the diversity of clients. So we deal with all the fields, the major fields of engineering that we're talking today. So we deal with design engineers. They have a problem, they contact us sometimes to help. Architectural engineers, we deal with them too. Manufacturing, we do sometimes during our repairs, we specify certain max because we need certain parameters to be used in the repair, so we deal with them too. Testing, we actually work with flood on a number of projects. So we deal with a lot of these, and even universities. We do research with universities. Sometimes we work for universities to do some testing for them. So you will be dealing with clients with different engineering backgrounds, and a lot of times too, you are just dealing with an owner who already has another engineer, but he got you and to fix the problems he have, and you are dealing with someone who doesn't have any engineering background. So you need, in a way, to educate him about the process, about your engineering process, to provide the solution for his problem. The third thing is a complete picture. So a lot of time in your master's or your PhD, you're focusing on one thing. Like, I was doing acoustic emission in my PhD. This is the whole thing that I was doing for like 2 years, just acoustic emission. And I'm doing acoustic emission now at WGE, but you're not doing acoustic emission just to do it now. You're doing it to solve a problem, right? So this is the whole thing. You always need to take a step back, and instead of focusing on the task or your area of expertise, you need to take one step back, look at the complete picture, understand the problems that your client have, and again, try to provide solution for this client. Because, as I said, and as I will say many times in the next slides too, consulting is all about solving problems, solving a puzzle. The last thing which was included in all the other presentations is always learning. May I be a little bit more here, because even like I do non-destructive evaluation, even if I know how to do like impulse response, every structure is unique. They are all different. You can't just go out and do the exact same thing and expect to get the same answer from a different structure. So you'll always be learning. I can say in my first year, I was actually kind of trying to educate myself on a new thing every single week. So you're always learning. It may get lesser as you have more experience and you build more experience, but you will always be learning. You have to expect that. So this is just a general background. I now want to talk about a little bit about more project examples, just to give you a glimpse of what I personally do and what you can do if you choose consulting to be a career path. These may not be the biggest projects I worked on, and a lot of our projects, again, are about problems. Most of our clients do not really like to say that they have a problem. So I will be limited on the amount of the information I can share, so it will be pictures, and I will say a few things that I can say and move on. So the first one, this is one of the first projects I worked on. It was really cool because it's a subway station. It's 40 feet below ground. That's a very thick retaining wall. Please don't take pictures. It was a retaining wall, 40 feet below ground, 6 feet wide. And what's the interesting part here is I'm a structural engineer by education, training, and licensing. And this was not a structural problem at all. This was more of a construction-related problem, which turned into a durability problem. When you say durability, it's cracking and eliminations and other things. So we went out, we did some non-destructive evaluation testing, and then went back to the office and provide repair details and repair specifications and mixed designs for the repair, and we're able to provide a solution to our client. The next project is very unique to me for two reasons. So you can see in here a picture of me with, like, these are two sensors. These are acoustic emission sensors, okay? So acoustic emission is like an emerging non-destructive evaluation technology. It has been used in the field for quite a bit of time, but it's not very widely used. So I got the opportunity to actually install an acoustic emission system to monitor an actual building. So that's my system here, that's me putting it. And we also have a vibration system on the same building. So this is the first interesting part, that I was able to take what I learned in the school during my PhD and my Master of Science and actually apply to a field structure. And then the second interesting part is that this building has a very unique structural system. It's like a tree. So you get a concrete core in the middle, and then trusses coming out from that concrete core, and then steel columns hanging from the trusses. They are not touching the ground, so it's literally like a tree. There were only 5 that were built in the US, only 1 in service, which is the one we're monitoring here. So, and we're monitoring it to keep it that way, and so that was unique and interesting to work with that unique structural system. Here you can see me in one of the examples of the diverse projects we work on. So that's a storm drainage tunnel, which is a fancy word for like sewers, but for drainage system, so just water, storm water. There's a lot of these in Chicago. Chicago is a very old city. A lot of them were built in the 1900s, and their walls are deteriorating. So what they want to do to keep them in service is they go in and they line them with different products. And what we are doing here is more of a quality control, quality assurance testing. But instead of going in, because these are miles long, so instead of going in every 50 feet and taking a core to check the thickness of the liner or to check the compressive strength of the liner, we actually worked with the contractor to develop a non-destructive evaluation plan and provide it to the owner of these tunnels, and they agreed on it, and we went in and we did these tests for, I think, 12,000 feet or something. So that's like 2.5 miles or 3 miles, and we do this every 50 feet. And so this is a very cool example of what we can do to help the client save a lot of money, because also if you core these holes, you need to repair these holes, while non-destructive evaluation, you just do it and move on. So going from a sewer tunnel to going up to a suspended scaffold, this is in downtown Chicago, Illinois, about 100 feet high. And here we are again doing non-destructive evaluation testing to check if the concrete has voids inside or it's a sound concrete. And the last example is very unique for civil engineers in general, I think. So if you look at this, you can see artwork in the background. These are pictures of art, and that's a museum. So we work now a lot with museums to do what we call vibration control plans. So, you know, museums near construction sites, they usually have a concern that the vibration from the construction will not damage the building, but will transfer inside their building and damage the art that they have, because this art is usually fragile and old and so on. So what we do is we go in and we turn their buildings into a big lab. We put like 40 sensors on the floors or more, more or less depending on how big the building is. And then we work with the contractor again, there's a lot of collaboration, to ask him to come out with equipment, and he tries equipment that he's gonna actually use during the construction. Then we get this data, and we process the data, analyze the data, and then we designate like safe areas in the museum where the art can stay, or areas where the art has to be moved. And then we also put a permanent remote monitoring system during the construction project that can send alarms and can also give you an indication of what the levels of vibrations are, so you can call the contractor and maybe change the means and methods. For concrete, most of the times they are very safe in these limits because the limits for art are much lower. But again, it's an area that I never really thought I would be working on. So what are the challenges? Our first challenge is if you go to a doctor and you are sick, you expect him to give you medicine right away. Pretty much the same here. Clients come with a problem and they want the answer right away. They may not have the money to repair it, but they don't care. They just want to know the answer. Do they need to repair it? No, or no, they don't need to repair it. So a lot of the time you will be working under like time constraints, and then you always get a new project while you're, again, finishing up other projects, but you need to manage your time efficiently enough so that you can provide timely services for all your clients. The other challenge is you don't usually always work in ideal conditions. I would say that this was much less than ideal because we were asked to go out in December in Illinois, which was single digits. So this was like 9 degrees Fahrenheit. That's a river right here. It's all frozen. And we are putting on a remote monitoring system with solar panels, and we're hoping that they work, and they did. But the point is, like, we spent 14 hours in the field to maybe do something that could have taken us 4 hours if it wasn't that cold, but because it was extremely cold. We spent a lot of time out there, and we got it done, but it wasn't really ideal situation, but you deal with this sometimes. Other situations that are challenging too might be like a tight time schedule. So if you're working with like a power plant and they have a scheduled shutdown for 2 weeks, then you need to go in these 2 weeks and finish all your inspections and go out before they can reopen that power plant, nuclear or not. They're all the same in this aspect. Then you can also have challenges related to access. Maybe you don't like heights and you need to go on a scaffold. So these are different things that you need to consider. I showed a lot of pictures from the field. This is not all what we do, a lot of desk work too, but I think this is more cool. But I would say about 25% of your time would be out in the field, at least. So ACI impact. So coming from Egypt, one of my personal dreams was to be part of ACI. I always dreamed of publishing papers in ACI, and I did that in grad school. But then I also joined ACI once I came to the US. I started coming in 2010. Now I'm the secretary of ACI 444, which is structural health monitoring and instrumentation, that's what I do. I'm a voting member in 342, which is bridge evaluation, because I do a lot of concrete bridges as well. And I'm also a member of 437, which is load testing. So what ACI can help you with is you want to come here, you want to learn from the experts in the field, you want to sit in these committees, see how they write their codes, write their specifications, develop their standards, but at some point you also need to come back and contribute to these documents. So it's a two-way street. So now you come, you learn, then you come back and contribute and make an impact to your field. So there are various fields in consulting. I'm just giving some examples of a field and then what committees might be applicable to it, but this is not all-inclusive list. There's a lot of other things that I won't go through, but like if you're working with bridges and infrastructures, there are ACI 342 and ACI 345, two committees that you can work with. If you're working in marine structures, ACI 357, which is offshore and marine structures, is also a very good committee that you can work with and learn from. Corrosion service life modeling, there are two committees, one for each. ACI 222 is for corrosion, and ACI 365 is for the service life modeling. If you are doing laboratory materials evaluations, there is a whole suite of committees that I didn't put. I just put like 200 committees. All these committees can help you, and a lot of our work is also doing stuff in the lab. So, like my company we own our own lab. We have concrete labs, structural labs, chemical labs, petrographic analysis labs, because it's all like tools that can help you to solve a problem. Then load testing and instrumentation, again, this is what I do. You can see how happy I was putting some sensors on a bridge here on a 120-foot forklift. And by the way, this is when I knew that I'm not afraid of heights, because this was my first very high above the ground job. But again, I'm a member of these two committees, and I'm a secretary for this one. And if you're doing non-destructive evaluation, there is 228 and 228B, which is non-destructive evaluation and visual inspection. And of course, big part of consulting is repair and rehabilitation, and ACI now has a full code document, ACI 562, just for repair. And also there is another committee, is ACI 563 for specifications. So again, this list is not all-inclusive. There is a lot of different fields in consulting that if you join consulting, you can work in and choose from and basically forge your own path and area of expertise. And thank you.
Thank you so much to all of our speakers.